In September 2020, an oceanic and atmospheric phenomenon known as La Niña developed in the Pacific Ocean between South America and Indonesia. There's nothing unusual in that, of course. La Niña is the meteorological sister of El Nino, which you've no doubt heard of. And together they form what's known as the El Nino Southern Oscillation, or ENSO system. Over time, the system moves through different phases of La Niña, El Nino, or neutrality, with a new phase typically developing between late summer and early autumn and lasting until late spring of the following year. What made the 2020 La Niña phase unusual was that it didn't last for 3 seasons. It lasted for 3 years, prompting scientists to refer to it as the triple dip La Niña. And for reasons that we'll get into a bit later in this video, that triple dip had the effect of reducing the amount of additional warming in the Earth's atmosphere. But even with that unusual duration of temperature suppression, our planet still experienced 3 of the warmest years ever recorded in 2020, 21 and 22. That's all changed now though. At the time of making this video, which is April 2023, the ENSO system has moved away from La Niña and is currently in a neutral phase. According to the US National Oceanic and Atmospheric Administration, or NOAA, all the signs are now pointing to a strong El Nino system brewing up for this summer and into 2024. And I'm sure you're well ahead of me here, folks. Yes, you've guessed it. El Nino does the opposite of La Niña. It puts additional warming into our already warming global atmosphere. An early indication suggests we're heading for a major bounce back from 3 years of oceanic heat absorption during La Niña. So, brace yourselves. Hello, and welcome to Just Have a Think. In a normal, unremarkable year across the southern Pacific Ocean, warm, moist air rises very high on the Asian side during the late summer, causing the unsettled weather and heavy rainfall patterns that are typical of that region at that time of year. The high-level warm air then returns across the Pacific back down to the lower, cooler east side, perpetuating the phenomenon we call the trade winds. Occasionally, though, those winds weaken significantly and the warmer waters flow back to the South American side, usually reaching their strongest point along the coast of Peru around Christmas time, which is why Peruvian fishermen nicknamed this phenomenon the Christ Child, or El Nino, which literally translates as the son or little boy. During an El Nino phase, it's the rising air in the eastern part of the Pacific that causes more stormy and raining conditions over here. Meanwhile, the air over in the western Pacific is descending, which tends to cause conditions that are more stable than average. Eventually, those pressure changes influence global atmospheric circulation, which means the phase and intensity of the ENSO system can ultimately affect seasonal weather patterns in both the northern and southern hemispheres. There's another lesser known driver of ENSO conditions though. It's a difference in air pressure from east to west as measured between stations in Darwin, Australia and Tahiti, slap bang in the middle of the Pacific. It's known as the Southern Oscillation Index, or SOI. A positive SOI represents higher air pressure over Tahiti, which tends to cause the stronger easterly trade winds that are typical of a La Niña phase. What we've got at the moment though is higher pressure at the Darwin end, which is weakening the trade winds and allowing the warm water to drift back towards the eastern side, as this NOAA animation from the start of this year demonstrates. It's this that has prompted NOAA's Climate Prediction Centre to issue an official El Nino watch for 2023. They've already got their beady eye on 2 hotspots, one off the coast of South America and the other one up in the northern Pacific. These 2 boxes represent what meteorologists call regions 1 and 2 of the ENSO system. And if we look at them in graph form from May 2022 to April 2023, you can clearly see a dramatic jump up in temperature in that region over the last couple of months. That matters because regions 1 and 2 are regarded as the best indicators of the potential strength of any incoming El Nino. And if we compare this year's changes to the changes experienced immediately prior to the 8 strongest El Nino phases in recorded history, you can see that the current sea surface temperatures are right up there in the thick of it. The result is that both the European and North American forecasting agencies all agree that we're looking at a strong El Nino stretching right across the southern Pacific Ocean. So that's all very dramatic and colourful, isn't it? But what does it mean for weather patterns in various parts of the world? Well, one likely piece of good news for you folks over in the States is that stronger wind shear and higher pressure over the Atlantic caused by El Niño events tends to reduce the overall number of hurricanes and tropical systems welling up in that region and rolling into the Gulf of Mexico. That doesn't mean North America is off the hook though. Far from it, in fact. During the winter, low pressure in the North Pacific pushes the polar jet stream further north, bringing warmer than normal conditions to the northern states and western Canada. But El Niño also amplifies the southerly Pacific jet stream, bringing lower temperatures and extreme storms to these southern states. This overlay shows the average winter pressure patterns for all the El Niño events since 1983. You can see the very low pressure air over the North Pacific pushing high pressure into Canada. That Pacific low pressure flows right across the lower half of the US, creating a potentially devastating storm track across these southern states. And here's how that looks in terms of temperature anomalies for the same time period, with far warmer than average conditions over Canada and much colder than normal weather down south. Weather changes in further flung parts of the world are less predictable, largely because local weather systems and other global weather drivers tend to muddy the forecasts significantly, especially at this early stage of the El Niño phase. But make no mistake, El Niño's effects are definitely felt in every corner of the planet, especially during a strong event like the one we're possibly heading towards now. We can get a fairly good idea of the potential by having a look back at previous strong El Niño years. 2016 is, so far at least, the warmest year on record, driven largely by a strong El Niño. But the strongest El Niño on record actually happened almost 2 decades earlier, back in 1997. The amount of energy transferred across the ocean during that event was equivalent to 100 times the total energy consumption of the entire human species over a whole year, which for those of you who like their data in cold hard numbers equates to 35 million billion joules of energy, which is a lot. And that changed the world's weather systems profoundly. California suffered extreme rain and mudslides. Dozens of people were killed during extreme weather events in Peru, with thousands more left homeless. There was freak rainfall in Kenya that year as well, about 100 centimetres or more than 3 feet above average. And Hurricane Pauline delivered 90 centimetres of rain to western Mexico in one day. Meanwhile, over on the other side of the Pacific, Indonesia experienced extreme drought conditions. It's not just these massively impactful weather events that are a cause for concern though. The real biggie is the fact that when all that pent-up oceanic energy gets liberated up to the surface, it can really turbocharge the warming of our atmosphere. And we really need that, don't we? So what about that El Niño fueled record hot year in 2016 then? Well, this model shows the Pacific temperature changes as El Niño developed during the course of that year. According to the United Nations, the 2016 El Niño impacted around 100 million people worldwide. It also caused permanent damage to coral reefs and a significant upsurge in carbon dioxide emissions from all the forest fires that happened as a result of extreme heat in many parts of the northern hemisphere. Ethiopia suffered 2 consecutive failed rainy seasons in spring and summer, causing the worst drought the country had suffered for decades. More than 10 million people were in need of emergency food, 2 million needed emergency water, sanitation and hygiene, and 1.3 million were made homeless. And millions of other vulnerable people were adversely affected across Africa, Central America, Southeast Asia and the Pacific Islands. Average global ocean surface temperatures in 2016 hit 21 degrees Celsius. That was the highest average temperature since satellite records began back in the 1970s. And here's a bit of bad news for you. NOAA tell us that the average global ocean surface temperatures in 2023 have already beaten that record. They now sit at 21.1 degrees Celsius or 70 degrees Fahrenheit. The 3 years of the triple dip La Niña that we've just experienced suppressed the atmospheric warming effect of rising greenhouse gas emissions. Our climate scientists tell us that more than 90% of the extra heat caused by cumulative emissions since the Industrial Revolution has been taken up by our oceans. Measurements from the top 2,000 metres of the ocean show rapid accumulation of heat in the upper layers, especially since the 1980s. Heat absorbed into the tropical Pacific is now extending down to a depth of more than 100 metres. And according to Dr. Kevin Trenberth from the US National Centre for Atmospheric Research, in this recent Guardian interview, that increased absorption will cause more extreme and long-lasting marine heat waves, which are classified as an area of the ocean where temperatures are in the top 10% ever recorded for that time of year for at least 5 straight days. Those heat waves have devastating effects on marine wildlife and cause coral bleaching on tropical reefs. Experiments have also suggested that warming oceans could be promoting a greater proliferation of algae blooms, causing damage to marine ecosystems. And of course, hotter oceans provide more energy for storms, jeopardise ice sheets and push up global sea levels. So it looks like we could be set for a record-breaking year. Unfortunately, it's a record that our planet could well do without. That's it for this week. Thanks as always to the channel's fantastic Patreon supporters who keep me on the straight and narrow and help keep ads and sponsorship messages out of these videos. You can get early access to every one of my videos, plus other exclusive content from me, and the chance to vote for future topics by joining those folks over at patreon.com/justhavathink. And of course, you can hugely support the channel absolutely for free by subscribing and hitting that like button. We're getting tantalisingly close to the 500,000 subscriber mark now, so if you can help us get there, then you'd have my undying gratitude. It's dead easy to do if you're on a PC, laptop or mobile device. You just need to click down there or on that icon there. As always, thanks very much for watching. Have a great week and remember to just have a think. See you next week.